everyone. Today we're going to have the properties of regular polygons. So there's a definition for the regular polygon here. Regular polygons are polygons that are equiangular. Equiangular means there are two words that are being combined here, equal and angle. So that means equiangular means all of the interior angles are equal. So each of these angles that we have here, or each of these corners, are equal to each other. Again, the word equiangular comes from the two words equal and angle. So it's equal angles. And then a regular polygon is also equilateral. Equilateral comes from the word equal. Lateral means side. So what does this mean? So each of these angles are equal to each other. They're all congruent. So I'm going to label them as just one tick here. I'm going to put a tick mark. That means all of these red angles are equal to each other. Whatever the measure of the one angle, the rest of them will have the same measure. And then it says equilateral. That means all of the sides are equal. So this side and all the rest of the sides would be equal to each other. So this is what is called as a regular polygon. Let's count how many sides there are. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a regular nonagon since there are 9 sides. Okay, so our task in this example is to determine the measure of each interior angle. So since each of these would be equal each other, what is the measure for each one of them? In the previous video, we talked about how to determine the sum of the interior angle of any polygon, and we got this formula right here. And then I will put the link of the video that talks about the sum of the interior angle of a polygon in the description box below. So this is the formula right here. So then from here we can go ahead and determine what is the total what is the total interior angle of this polygon. So that would be sum of the interior angle is equal to 180 times n is the number of sides minus 2. So from here we wanted to determine the sum. What is the total for all of these? So that would be 180 times, this is a nonagon, so that means there are 9 sides, 9 minus 2, so this is 180 times 9, times, we have 9 minus 2 is 7, so 180 times 7 is 1,260. So that's the sum for all of these. So if I total all of those red angles, that would be 1,260 degrees. That's the sum for all the red angles. Now, since each of these angles are equal, so then we can go ahead and determine the measure of each. So I'm going to write here the measure of each interior angle. So the measure of each interior angle would be the total divided by the number of angles. In this case, there's like 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the total is 1,260, I divide this by 9. And so the answer for this is 140 degrees. So each of these corners here would be 140. So that's 140. This one is also 140. So each of these would be 140. So that if you add all of this 140 degrees, it will have a total of 1,260. At this time, I would encourage you to pause this video and try this problem out on your own. We have a regular 20 gon. And if you're done, and pause it and check your answer. Okay, so we go over the problem here. So it's pretty much the same thing. We don't have a picture for this, but we can solve for the total of the sum of the interior angles. So I'm gonna take the formula up here so that we can use this up in this problem here. So the sum of the interior angle is so that's gonna be sum of the interior angle is 180 times n minus 2. So then that is 180 times our n, or the number of sides, is 20 minus 2 equals 180 times 18, because we have 20 minus 2 is 18. So then the sum of the interior angle of this 20gon is 3,240. Now we want to determine the measure of each interior angle. So the measure of each interior angle. So one angle, what is it measure? So that would be 3,000 the total. So 3,240 divided by there, since there are 20 angles, so that is divided by 20. So that means it's 162 degrees. So that is the measure of each of the angles in this regular 20gon. Did you get the same answers as this? Good. Perfect. Now let's have the last notes right here. So we have we've talked about the interior angle. So what about the exterior angle of a regular polygon? So there is another video that talks about the exterior, determining the sum of the exterior angle of a polygon which is not regular. I will put the link of that video in the description box below. So this was the we always remember that we got this from the previous video. The sum of the measures of the exterior angle of an n-gon is always 360. Now, if it's a regular polygon, each of these exterior angles that we have here, I'm gonna label this in red. So each of these red angles are equal. So they are equiangular. The reason why they're equal, it's because this is a regular polygon. So then we can still use the formula that we got from the other video on the general sum of the exterior angles of a polygon, which is 360. So all we need to do is we have 360 divided by, so that's going to be 360 divided by, we count 1, 2, 3, 4, 5. So 360 divided by 5 is 72 degrees. So that means since in a regular polygon, the each of the exterior angles are equal, so that means this is 72 degrees. This is 72 degrees, this is 72 degrees, this is 72 degrees, and this is 72 degrees. So pretty much we divided 360 by the number of sides. So if you add all these 72 here, it will come out 360. If you find this video helpful, hit like and subscribe for more math videos. See ya!